Let's look at quotient rule plus standard derivatives in the same question. So these look quite complicated, but in fact they, generally speaking, are very simple. So number one, y equals sine x all over x. First thing, do not be tempted to cancel x's there. This means sine of x divided by x. It does not mean sine of x over x. So you can't write that as sine of x over x, which is the sine of 1. You can't do that, that's nonsense. So it's a function of x, sine of x, divided by x. So you decide quotient rule. It's a division of two functions. So u will be sine x, du by dx, standard result, you learn it off by heart, cos x. V is just x, so dv by dx is 1. Now we do the quotient rule. So dy by dx will be, you learn this off by heart, 1 over v squared, v du by dx minus u dv by dx. Make sure you practice writing this out every time you do a question because it'll stick in your head. Substitute in 1 over v squared. Well, v was x, so 1 over x squared. Square bracket. V is x multiplied by du by dx. Du by dx is cos x. X cos x. There's no need to put a bracket there. X cos x is fine. Take away. U is sine x. Notice what I'm doing. I'm putting sine x down, but putting a little gap at the front to insert the next term. So u is sine x. Dv by dx is 1. So I've got a 1 there. Put it at the front. 1 sine x. Put it in a bracket if you want. So there you go. Just tidy up. You've got 1 over x squared, and then inside the square bracket you've got x cos x, and then minus, and then that times that is minus just a single sine x. Now that's basically the answer. What we quite often prefer to do is now imagine saying 1 times the square bracket just gives you that. If you expand out by the 1, and then you're going to divide it all by x squared, so I put a big long line x squared like that, perhaps put a round bracket around that. So that there is equivalent to that statement there. That's probably the neatest way of writing down the answer. Notice there is no common factor of these two terms in the square bracket this time to take out as a common factor. And so there's the neatest answer. Very straightforward. So let's try another one, number 2. Let's do one like this now. Y is equal to, let's say I did cos x on the top all over x squared on the bottom. So in this example, it's a division of two functions. U is equal to cos x. Du by dx would be equal to minus sine x. Standard result. So v will be equal to x squared. So dv by dx will be equal to 2x. Okay, so now quotient rule, you quote it. Dy by dx is 1 over v squared. Learn it off by heart. V du by dx minus u dv by dx, like so, and substitute in 1 over v squared. So 1 over, well, v is x squared, that's v, and you've got to square it. So put it in a bracket and square it. Square bracket, v is x squared times du by dx is minus sine x. Now be careful, it's multiplied by minus sine x, so I must put this inside a bracket, because they're being multiplied together. Take away u is cos x times dv by dx, that's 2x. I'm not going to put the 2x at the end, I'm going to put the 2x at the front. So you get 2x cos x. Tidy up. Now be aware, 1 over x squared, and then all of that to the power 2 from your third law of indices in year 10. That's the same as x to the power 4. 2 times 2 is 4. Inside the square bracket, well, I've got a negative x squared sine x, and I've got a negative 2x cos x, like so. Now a bit of simplification first of all in this, because there's common factors going on. And I would say to you that there's an x in both terms, but there's also a negative quantity in both terms. So I'm going to take the negative and the x both outside. So I'm going to take a negative x, and then inside the square bracket, what does that leave you with? X sine x. That times that gives you that. And then it must be a plus, because a negative times a plus gives you a negative. and then I've got a 2 there and a cos x there. So negative x times that gives you that. So the top line changes to that, and then I've still got an x to the 4 on the bottom. Okay, in this particular example, you can now say divide the top by x and divide the bottom by x. So you're going to get minus 1 and then x cubed. X sine x plus 2 cos x. And I would just tidy up still further by doing the following. I would say minus 1 times that is the same thing as minus, round bracket now, this. So minus 1 times the bracket, I'm just dropping the 1 in other words, the 1 doesn't need to be there, so it's minus that, and then a big long line on the bottom with x cubed on the bottom. So that expression there means the same thing as that. If you divide by x cubed at the beginning, you can put it as a big long line over x cubed. And that's it, there's no more common factors. That's as far as we can take that question. So a bit more work involved in that, a bit more untidy. Okay, let's do question 3, turn over. Very straightforward. Let's have a look at this. Y equals e to the x over x. There you go, a very basic quotient rule involving exponential. U equals e to the x. Du by dx will be the same thing, standard result. V is x, dv by dx is 1. So dy by dx, quotient rule, learn it, 1 over v squared, v du by dx minus u dv by dx. Substitute in the 4 things. 1 over v squared. 1 over v is x, so it's 1 over x squared. V, x, du by dx is e to the x. No need for brackets. Take away. U, that's e to the x, times dv by dx is 1. dv by dx is 1. Put it at the front. Put it in a bracket if you want, but go at the front. 1 times e to the x. So 1 over x squared. And then what I'll do is, I think I'll take out now a common factor of e to the x from both of these. That e to the x goes outside and multiplies the 1 outside. So you get 1 e to the x. So you can drop the 1 and just write e to the x now. And now the square bracket I'm going to change to a round bracket. And this must be an x, take away a 1. That times that gives you that. That times negative 1 gives you that. So there you go, there's the basic answer. I may also just change it to e to the x, x minus 1, all over x squared. That's a slightly neater way of writing the answer. Okay, that's question 3 done. I'll do one more example for these basic quotient rule with standard results. I'll do an f of x notation this time is equal to log to base x over x. And don't forget, in this example, don't be tempted to write this as log of x over x. It's not the same thing as log of 1. Definitely not. This means log of x, share by x. You cannot cancel the x's. Okay, so here we go. U will be log to base e of x. Du by dx, standard result, 1 over x. V is equal to x, so dv by dx is simply equal to 1. So notation, f dash of x then for the gradient function, not dy by dx. F dash of x equals, quote the formula, 1 over v squared, v du by dx minus u dv by dx. Sub in the 4 things. 1 over v squared, well v is x, so 1 over x squared. V is x times du by dx is 1 over x. Put that in a bracket. Minus u is log x, I'll leave a gap there, log x, times dv by dx, which is 1. I'll put the 1 at the front. So equals 1 over x squared, and then inside the square bracket, again we've seen this in a previous example, x times 1 over x is just 1. The x is cancelled. It's like x over 1 times 1 over x, the x is cancelled. Take away 1 times log x is just log x. There's no common factor from this, so I can't do anything with that. But what I can do is say 1 times this bracket is just that, which I'll put as a round bracket. 1 times 1 is 1, 1 times that is that. and then instead of over x squared outside, I'll put it all over x squared like so. And there you go. That's as simple as it goes. So there you go. I've done 4 very basic examples applying quotient rule with standard derivatives.